Okay, good morning, ladies and gentlemen. Before we start 3.3, our product and quotient rules, we're only doing product rule today to try to conserve some time. Here are some derivatives you've already learned. These are properties of derivatives you already know. I'm going to say over the next week or so, you will be learning lots of derivatives. You need to memorize these now, and as they come, continually memorize them because you do not get cheat sheets on any tests or anything for your derivatives. Okay. First one that we know here, this is the power rule, number one. We know the derivative in terms of x raised to a power, where n is a number, it's a constant, is going to be n times x, and then we drop the power 1. We learned yesterday that the derivative of the sine function is the cosine function. And we also learned that the derivative of the cosine function is the opposite of the sine function. Okay, it's negative sine. Okay, we learned more than that. Okay, you learned that the derivative of a sum is the sum of the derivatives of the terms, like polynomials. We can take each term, differentiate it independently. We also learned the constant multiple rule. Kruger's way of the constant multiple rule is d dx for some k times x raised to a power of n, okay, where k is a constant and n is a constant. This derivative is simply the constant in front times that exponent when it comes down times x to the n minus 1 and drop the power 1. That's the constant multiple rule. Okay, you just got to take the exponent times the coefficient, and it gives you a new product that goes in front of that x, drop the power 1. Okay, well, today we are going to learn and see what is the product rule. Okay, well, the product rule is something completely different here now. I'm going to kind of go quickly into it here, but notice if I have f of x equals x squared times the cosine x, notice this is a function of x times another function in terms of x, and I cannot combine those. If I had something like f of x equaled x squared times x, okay, I would never use the product rule on something like this. Obviously, I would redefine my function as x cubed and say the derivative in terms of x, that's 3, is going to be 3x squared, okay? But notice I can't do these with this particular function, okay? So what I would like you to do is, if you were in here, I would say, okay, what do we want this derivative to be? It can't be anything we want it, but after teaching calculus for multiple years, typically most people are going to say, well, if I'm taking the sum and difference of derivatives, why can't I take the product of the derivatives? So why can't I just say it's going to equal 2x, the derivative of that x squared, times the derivative of cosine is negative sine x, to where it would be negative 2x sine x, okay? That is what most people would assume it is. Well, let's check it out once. This is a really wonky, cool graph. So what I would like to do is I'm going to grab here, and what I'm going to do is I'm going to graph the original function, x squared times the sine of x, or no, times cosine x, sorry, cosine x, and we get this really crazy graph. It's like, whoa, the blue one is my function. I want to come out, whoa, what's going on here? I want to come up here. No, come on, you pot licker. I want to come up here. I'm going to take that up to 20 just because it's such an impressively cool graph. We're going to make our windows a little bit bigger. And let's graph what we thought it might be. So I'm going to add the graph in here that we said. We thought, what did we think it was? We thought it was maybe negative 2x times the sine of x. And what I'm going to look here, it looks like, well, it almost looks like it lines up, except as soon as I start quickly putting that back, as soon as I start tracking my flats, okay, those are flat there, I should have a 0 here. A flat here, I should have a 0 here. When I'm looking at this blue one, I got a flat, I should have a 0. It looks like all my flats are off a little bit. Whoa, what did I just do? And so I just want to erase those. So although it kind of looks like it's there, it's not it. What is the derivative? Well, the cool thing here is we can come on. We can come here and we can come down to our template and we can say find the derivative in terms of x of f1 of x, and it'll graph it. That black one is actually my derivative, okay? And that's where I can see, if I came back here, let's turn that guy off, and I can see my flats now track, okay? So the black one is there. It's not what it is. So good thing we have a CAS calculator here. I'm going to add a page. I'm going to add a calculator page. I'm going to come back here to my template, and I'm going to say, what is my derivative in terms of x for x squared times my cosine of x, okay? Boom, there it is. Whoa, 2x cosine x minus x squared sine x. A little bit different than what we came up with here. So the actual derivative, if this thing works for me, actually f prime of x equals, it said it was, what did it say it was? 2x cosine x minus x squared sine x, okay? Now, what I'm going to do is I'm just going to have you come to these next two functions, and as we're going through, as you're doing these, what I want you to do is I want you to focus on something, okay? Because this is a function in terms of x, okay? We're going to think of this as some u of x and some v, function v times x, which means we're going to kind of look at it like that. My f of x function is going to be my function in terms of x times a completely different function in times of x. What is my derivative? Okay, and what I'd like you to do is I would just like you to turn the page here, and I would like you to type these next three only in your calculator and see what your calculator says what they are, and see if you can figure out the pattern over these next three problems. Hopefully you got these first three done, and what I did is I just copied the previous problem off the previous page there, and I said in that first problem we're going to say f of x equals x squared times cosine x, and we let the first function be a function in terms of x. That's u of x times v of x, okay? So we're looking at u of x times v of x. When I cross-reference any one of these, 1, 2, 3, or the example we did yesterday, watch how I can track where's my u of x. Let me track my function. Here's my u of x function. Where's my v of x? Here's my v of x function. Well, what the heck is this 2x here? Boy, it kind of looks like it's the derivative of my u function. And what is this sine x? Well, the derivative of cosine would actually be negative sine. So this is actually looks like the derivative, but because this minus, the negative right here comes with it, where if I took the derivative of u of x times v of x plus u of x times v prime of x, okay? Well, does that same thing hold true here? Well, let's let this first one look at u, and the second one we're going to kind of call v. Well, look it out. I can see here's my u. That looks kind of like a v. I better do, oh, son of a biscuit. Looks like, make sure I get a small little guy there. So here's my u, and sine, here's my v. Well, here's my derivative of my sine function. Well, that would be cosine. That would be my v prime. And the derivative of my x squared, well, that would be my 2x, that would be my u prime, and I'm multiplying those two and adding them. Well, before I took u prime times v plus u times v prime, here I took u times v prime plus u prime times v. Well, is that the same? Do they look like they're the same? Well, they're not. Kind of. We're going to keep investigating here. Here's going to be u times v. We'll track it. Where's my 3x squared? Here's my u over here. Where's my v? Where's my sine x? Here's my sine x. Here's my v. Well, where is my u prime? Oh, 3 times 2, that would be my u prime times v. And what's my derivative of my v function, my sine x? Well, that would be cosine, so there's my v prime. So add those together. Look at the last one here. Here's my u function, here's my v function. Where's my u? Here's my u. Where's my v? Here's my v. Where's the derivative? Where's the derivative of that one? I don't see it. I see the derivative of my cosine. Here's my negative sine. Okay, so here's my v prime. And if I took that negative and I hitched it with the sign for the negative, that would make that sign plus, right? But where the heck is my derivative of x? Well, what is the derivative of x? Oh, maybe I can see a times 1 there, and I have my u prime there. Well, notice addition is commutative, meaning 2 plus 3 is the same as 3 plus 2. The order in which I add things makes no difference. As well as my multiplication is commutative, meaning 2 times 3 is the same as 3 times 2. The order in which I multiply does not make a difference. What you do notice here, hopefully, is a pattern. Okay? Don't memorize a formula. Identify the pattern. Okay? What are we doing? Well, taking the u, first one, times the derivative of the second one here, plus we're taking the derivative of the first one here times the second one. Notice, here's u times v. Over here, I have a u, I have a v, and I have a v prime, and I have a u prime, and they're opposites, okay? Here, I have a u and a v, and a u prime and a v prime. So what is it kind of looking like? Well, if we tipsy-do here to 4 and 5, let's say here's u and here's v. Well, hopefully if we looked at this, we're saying, oh, f prime of x is going to be, and it makes no difference how you do it, we're going to have an addition here. We have a u, we have a v, and if I took the derivative, or the u here, I got to have a v prime times a u prime, okay? First one and the second one. So let's try this and check it out. Well, if I have u, this is going to be an x squared times, what's my derivative of cosine? That's going to be negative sine x plus my v is going to be a cosine x times my u prime. Well, that would be the derivative of that. That would be a 3x squared. Well, how would I actually arrange this? I would probably say it's negative x squared sine x plus 3x squared cosine x. Well, let's check it out. Is that what we get when we check this one in our CAS? Well, I'm just going to come up here and bring my template down. And in this case, we're taking an x cubed times a cosine x, and we get 3x squared times cosine x minus x cubed. Okay, well, is what I have written there, isn't that just rearranging the order in which I have things written on here? Okay, isn't that just putting these terms, isn't that just taking these guys and saddling in front of here and taking this one minus that one rather than negative this one plus the other one? Okay, so try these next two, see if you get them right. We got a u, we got a v. Well, I know how I'm doing this. How are you doing this? And most people are going to say, well, my derivative in terms of x is going to come, well, I need a u, And that's going to have to be multiplied by a v prime plus, I'm going to have a v times a u prime over here. And this is not the way I memorize it, but let's check it out. So if I put my sine x here, that's going to be multiplied, whoa, back up the thing here, Kruger, back up the train. My u function, there's my u, 3x to the fourth, times my derivative, sine is cosine, plus my derivative of v, ooh, that would be derivative of sine is cosine, times my derivative of this one, wouldn't that be 12x to the third times 12x to the third? So this is going to actually equal 3x to the fourth cosine x plus 12x to the third times a cosine x. Something's not right here, Kruger. What did you not do? My v is supposed to be a sine here, not a cosine. Let's come back in there. I'm not used to doing it this way. Don't like it. Oh, that's got to be different too. It's not sauce. Oh God, I got to get rid of that too. Pick up the pace here, bucko. Whoa. Those should be sine, shouldn't they? Because my v, sine, sine. Check that one in your little casserole here. I'm going to pull it up. Bring down that template. Over here, I'm going to come over, and here we got a 3x to the fourth. And that's a sine x. 3x to the fourth cosine plus 12x cubed sine x. Is that what I had written? I hope that's what I had written. That's what I had written. I'm skipping number 6. We're going to come straight to this template here, okay? And so, if I have a function in terms of x times a function in terms of x, what is my derivative? It's not just the derivative of the first function times the derivative of the second function, okay? I think of it as the derivative of my first function times my second function plus the derivative of my second function times my first function. And it comes right in there. Now, it can be written in a different little shorthand. These are written in terms of x. If I say, what's the derivative of u times v, where u and v are differentiable functions of x, these are functions of x, so I always say derivative of the first one times the second one plus derivative of the second one times the first one. And my u's and v's look, well, why don't you use g and h? Because, I don't know, calculus books love u and v for all these if you ever looked it up or looked it into your book to remain consistent with that. So we're going to do a couple practice. Actually, I'm going to come back here and I'm going to practice number 6 with you really short and quick. Okay, again, here's the first one, here's the second one. First one in terms of x times the second one. So I say f prime of x is, I always say the derivative of the first term is 6. That's going to be multiplied times my second one, cosine x, plus the derivative of cosine is negative sine x times my second function, 6x. And then I just clean it up really quick and I say 6 cosine x negative minus 6x sine x. Okay, that is what my derivative will be. Yes, I can factor a 6 out of there. We'll get into the solving of these in a while, but let's go. Woo, woo, woo. Did you say do some practice? Well, there's 2 ways to skin a cat here. Notice this is a polynomial times a polynomial. Okay, do I have to have the product rule to do this derivative? No, I could totally redefine this function. I could double distribute and I could call this 2x to the 5th plus 4x squared plus 5x to the third plus 10. And I could redefine it as a big ugly polynomial and say, oh, y prime, my derivative is 10x to the fourth plus 8x plus 15x squared. And I would never leave it that way. I hope you would never leave it that way because it's not in descending order. It's 10x to the fourth plus 15x squared plus 8x. That is the appropriate way to write things in math, descending order. Does that mean the product rule doesn't work? This is without product rule. With the product rule, here's my u, here's my v. My derivative would be as follows. What is the derivative of u? Well, the derivative of that is going to be 4x, and that's going to have to get multiplied by the second term, which is x cubed plus 2, plus the derivative of my second term, that's going to be, or my second product, or my second function, I should say, is 3x squared times the first one, 2x squared plus 5. Again, are these the same? Well, we certainly couldn't leave it this way, so we would have to call this and say it's 4x to the fourth plus 8x plus 6x to the fourth plus 15x squared, and I have a couple x to the fourths gives me 10, x to the fourths. I have a plus 15x squared plus 8x, and that's what my derivative is. To be completely honest with you, if I had my choice of taking a derivative of this type of function, I would usually redefine it like that and just use my power rule quite a few times rather than look at it as a product. Many times I will keep it as a product. It just depends how ugly the function is going to be. Okay? Find using the product rule, I'm just going to say, why would we? This is a constant times a function. This is not a function of x times a function of x. This is a constant times a function of x. This is, bring my power times my 6, 30, x, drop my power 1. I would never, ever use the product rule on something like that, okay? Just wouldn't do it. When I come here, how about here? This is a tricky one. Give this one a try, and I will be back. Okay, hopefully if you got to this point, you're semi-correct, okay? If you got this down to y prime equals negative sine squared x plus cosine squared x. Kruger would say that is not simplified yet. Basically, here's my u function, here's my v. If I take the derivative of my first function, derivative of cosine is negative sine, times the second function, times my sine x, plus the derivative of my second function, derivative of sine is my cosine, times the first term, or my first function, which is cosine x. Well, negative sine x times sine x is negative sine squared x, plus cosine times cosine is a cosine squared. This actually is a cosine double angle identity, yes? Remember all those identities? The simplest form for this to be would be a cosine 2x is what y prime equals. Do I really need to know it comes down to a cosine 2x? What I'm going to say is, sooner or later, we're going to be finding zeros, horizontal tangents of products of functions. This one is much more difficult to find out where the horizontal tangents are than this one, which is the whole point of all the work you did, one of the points with all the work you did in pre-calc with your trig identities. I will soon be posting a nice trig identity sheet back on the website if it's not on It's Learning, if it's not there. The last problem we got right here is we're going to find the derivative of this. If this were me, here's my u function, and I don't even think of them as u and v, okay? That's not the way I operate with it. I think of my first function times my second function. So I would always say my derivative is the derivative of the first function times the second function plus the derivative of the second function times the first function. And then I clean it up and I say 14x cosine x. Positive negative means minus 7x squared sine x would be my derivative, okay? It was kind of a compressed lesson for the product rule, but I can tell you, you should be able to go on to page 124, and you should be able to do number 17, 21, number 23, both parts B and C, number 29, and and on the next one, I have number 7 and 8 written here for some reason. And I think that's because there's another page on there. And yes, because then that's on page 146. You should be able to do number 7 and 8. And then also, you should be able to do number 6 from yesterday's worksheet. Okay? You do not need to monkey with the J1 worksheet at all. There's going to be time to work on that in class if you're coming back to school next Tuesday. After our formative on Tuesday, after the formative's done, you will have time the whole rest of the time to work on that worksheet, to ask questions on it. If you want to get it done, feel free. All the other problems that are not listed here will come out on Monday for the quotient rules worksheet. Have a good rest of your day.